Hello friends, welcome to this video. We are going to graph quadratics and then identify these key features or characteristics about them. Alright, so looking here at this first example, we first need to understand the equation that we are given. It says y equals negative x squared plus 2x. When we look at this, you should be thinking that this is in standard form for us. The only thing that's missing is our c value. So if you need a c value, you can put it in, it's plus 0. Okay. Once we have that information, we really know where to start and how to get what we need. If we are going to graph a standard form of quadratic, then the best place to start is to find your axis of symmetry. So this is where I would start first. This is going to tell me where the middle of this graph is. It's going to tell me where the symmetry falls on this graph. And to find that, remember, we're going to do negative b over 2a. So here we're going to take negative, our b value, which is 2, and we're going to divide it by 2 times our a value, which here is negative 1. When we do this, we're going to get a negative 2 over a negative 2, which gives us a positive 1. So our axis of symmetry is going to be at x equals 1. So I'm just going to go ahead and draw that in here. This tells me that that should be the middle of the graph, and the left and the right side should be mirror images of each other. That helps me know where to look on my table. All right, so I'm going to draw an xy table. I know that 1 should be right in the middle. So let's get 2 points that are smaller than 1, so when x is 0 and x is negative 1. And get 2 points that are going to be larger or to the right of that, where x is 2 and x is 3. The easiest way to do this then is let's use our graph or our multi-view calculator, and we're going to do table, and we're going to type in our function negative x squared plus 2x, and then when we hit enter, we're going to tell it we want the table to start at negative 1 and step by 1, and go ahead and hit OK. And we find out when x is negative 1, y is negative 3, when x is 0, y is 0, when x is 1, y is 1, when x is 2, y is 0, and when x is 3, y is negative 3. So I'm going to fill those in. Negative 3, 0, 1, 0, negative 3. So let's plot them. Okay, negative 1, negative 3 is all the way down here. 0, 0 is here. 1, 1 is here, so that's on my axis of symmetry. That means it should be the middle. Then we have 2, 0, and then we have 3, negative 3. Noticing that these points on the left and the right are mirror imaging across that axis of symmetry. So let's go ahead and connect these. Let's draw our nice quadratic. We should have a parabola. Okay, I'm putting some arrows on the end to remind myself it's going to go on forever. This allows me to know, hey, here's my vertex. It's going to be right here at the very top. So the vertex is at 1, 1. We also saw that right there. From my vertex, remember, we should know the x is going to give us our axis of symmetry, and the y value is going to give us our max or min. Well, here, since it opens down because of this negative in the front, that means that we're going to have a maximum. So our maximum is going to be at the y value of 1. All right, so our domain and range, here I'm going to look at the ends of my graph. This end goes down and left, so these are both going to approach negative infinities. This one's going down but right, so the down approaches a negative infinity, but the right is going to approach a positive. Remember, when we are looking at our domain, we're looking left and then looking right. These are our x's. So it's going to go negative infinity to positive infinity. While our range is our y's, so that means we look down and then look up. So as we look down, we see that we're going towards negative infinity. And when we look up, we notice that we don't go any higher than the y value of 1. We're going to put a bracket on that because it's an endpoint. All right, so now we're going to find x-intercepts and y-intercepts. And our x-intercepts are very nice and clear on this because we actually saw them on our table, so they were nice whole numbers. So we have an x-intercept at 0, 0, and we have another x-intercept at 2, 0. Then our y-intercept is also 0, 0. Remember, if your x-intercept is 0, 0, then your y-intercept will also be 0, 0. All right, so let's talk about those intervals of increase and decrease. Remember, these are going to be x's where you have positive slope and negative slope. So positive slope for increase, negative slope for decrease. So the whole left side, if you move your finger from left to right, notice that we are moving up. So that means this has a positive slope on the left side. As you move your finger from the middle to the right side of the graph, notice you are putting your finger downward. That's a negative slope. So we're saying that the axis of symmetry separates the left side that has positive slope from the right side that has negative slope. So my positive slope side was the right side. So that means from negative infinity until the axis of symmetry at 1 is where we have increasing slope. Then our decreasing slope is going to be everything from our axis of symmetry at 1 and to the right, okay, to positive infinity. Our end behaviors are going to tell us what the y values are doing as we look to the ends of the graph. Quadratic functions, both ends should be going in the same direction. So notice both ends here are going down, so that means my y values are going to approach negative infinity. And then we have an average rate of change, which means what's the slope, and we want to know the slope from when x is 0 to x is 3. Well, what's nice is we've already identified on our table where x is 0 and y is 3. X is 0 at 0, 0, and x is 3 at 3, negative 1. So that's this point, 0, 0, and then 3, negative 1. So if you didn't want to look at the table, then you could always just look at the graph and go to the x value of 0 and find where it's on the graph, and then go to the x value of 3 and find where it touches the graph. So what we want to do is we want to find the slope, the average rate of change between these 2 points. So that means from the left point to the right point, we want to count rise over run. So notice our rise is actually going to fall. We are actually falling 3, so that's a negative 3. And then we're going to go over to the right 3. Now don't let the lines be deceiving. Each line here is half. So that means every 2 lines equals 1 whole. So we are going to go down 3 and to the right 3, which gives us an average rate of change of negative 1. Okay, so go ahead and pause the video here and just do the next problem after that and check it with my answer. Alright, so here's the answers for the next problem. So as you know, it's standard form. It should be opening down, which means we're going to have a max. Okay, the thing that was a little bit tricky about this one was your x-intercepts, and yes, you do need to actually find those values. And what's nice is you have an equation. You know the standard form, so you can use the quadratic formula to find those exact values. So you'll see I put the quadratic formula in there, and I found my 2 x-intercepts. Okay. All right, so let's look at the next one. It looks a little bit different just because it's given a different form. This is not standard form. This is called vertex form, which means the first thing we want to plot is actually, or find, is the vertex. The vertex comes from our h and our k value. Remember, it's the opposite of h, so that's going to be a positive 2, and the k stays the same. So we have at 2, 4 is going to be the vertex. So that means from there, this thing, well, it's a positive in the front, so it's going to open up. That means that is going to be a minimum, and it's a minimum value at y equals 4, and your axis of symmetry is going to go through 2. And I got all that information just from my vertex. Okay. Then let's go ahead, since we know where the middle of the graph is, let's get a table. So the middle is going to be when x is 2, so let's go 2 to the left and 2 to the right. Let's use our table and type in the function. So x minus 2 squared plus 4. We'll start this one at 0 and step by 1. And we're going to get an 8, 5, 4, and then a 5 and an 8. So 8, 5, 4, 5, and 8. And let's plot those points. So when x is 0, y is 8. When x is 1, y is 5. When x is 3, y is 5. And when x is 4, y is 8. So we see our nice quadratic here. I'm going to plot it. There's my parabola. And then let's get the rest of the information. So this arrow goes left towards negative infinity and up towards positive infinity. This arrow goes up towards positive infinity and right towards positive infinity. So domain is left, x and left and then right, so x's. So negative infinity to positive infinity. And then our range is our y, so that means down and then up. So as we look down, the lowest our graph goes is this 4. That's an endpoint, so it gets a bracket. The highest the graph goes is up forever towards positive infinity. All right, x-intercepts, we're looking at the x-axis. We do not touch or cross, so this is none. And our y-intercept, where we touch or cross our y-axis, is right here at the point 0, 8. All right, so when we talk about increasing and decreasing, the left side of this graph, if you trace it with your finger, goes down from left to right, so negative slope. And then the right side is going up from left to right, so positive slope. So everything to the left of the axis of symmetry has a negative slope, and everything to the right of the axis of symmetry has a positive slope. So that means left of the axis of symmetry is the decreasing side, so that means smaller, so negative infinity to positive infinity, up until the 2 of the axis of symmetry. And then the increasing, where you have positive slope, is from the axis of symmetry at 2 to positive infinity. The end behaviors, both ends of this graph are going to go up, so the y values are going to go up towards positive infinity. And then we are going to find the average rate of change, so the slope, from where x is 0 to x is 2. So when x is 0, that's up here at my y-intercept. When x is 2, that's down here at the vertex. So we're going to count the slope from left to right. So this is going to fall, so down 4, and then to the right 2. So we have down 4 to the right 2, gives us an average rate of change of -2. Okay, so go ahead, pause this video, do the last example that is underneath it, this one right here, and then come back and check your answer. All right, so here is that last example. It should be opening down. Your vertex is at -1, 4. From that, you get your axis of symmetry and your max, which is at y equals 4. Domain is negative infinity to positive infinity, range from negative infinity to 4. Your x-intercepts are nice, and they're there, plotted for you already. You don't have to solve for them. Your y-intercept, nice and pretty. The left side of the graph is the increasing slope. The right side of the graph is the decreasing slope. It's split by the axis of symmetry. Both ends open down, so going towards negative infinity. And the average rate of change from -3 to 3 is going to be 1. All right, I hope that this helped. Have a good day.